whole period, so they're going to ask you, they just ask you the period, okay? So for this one, they can ask you instantaneous one, at that particular moment. Okay, so they show you everything again. This one, if you show me working, actually no need working. Just write. Sorry. That's zero. So when he asks you when is this, it will occur when it's +2. Okay? Minimum when it's -2. So when is it? It's 25 and 125. Okay? This one. Hey, do you know what they're drawing below? No. What they're drawing is trying to show you, if you remember, FM is talking about we change the frequency together with the voltage. So the pattern, so they're just changing the values. So this is fluctuating between 110 and 90. The one is between 2 and -2. So it must look the same pattern. Even the phase must be the, even the time must be the same, except the value is different. Okay. So if they ask you to draw this, be very careful because most people might forget what to draw. This is not very common. This is not a common thing. Okay. So don't fall into the trick. Okay. So this is what they normally call the voltage control oscillator. Okay, so sometimes for those who do motor, you realize that if I want to control the motor, how fast it turns, I can control it by using voltages. The slower, the little voltage will cause it to move very slow. And the turn, increase the voltages, it turn faster. Okay, so it's the same idea. Okay, using voltage to control the frequency of turning. Okay, basically, motor or wheel is turning. Okay, so this is talking about proportional. This is proportional. This is proportional. Okay, so these are some of the things that you can use. Okay, whatever you do there, you have to do the opposite on the other side. Okay.
Demodulation.
Yes, whatever you do there must be the same. You can see they are comparing it's the same. Okay, so from frequency use back to voltage. So I'm just doing a quick part. Am I looking at the same chart, same table? It's the same. So this one must be made known to the other side. If it's not known to the other side, of course they cannot demodulate. Okay, there's so many thousand possibilities. So you realize they draw a thing upside down.
The line upside down.
Yes. Just now we draw voltage frequency. Now they draw voltage and then frequency. So what does this? How can I draw this
Frequency
from here? Okay, one simple thing is what you can do is that
yeah.
okay. Another way is that you can think of this one topple this side. Right? Or if you prefer not to, then we start from scratch. First, just now what is our F, our y-axis? Our y-axis is F. Now this one is upside down. Okay, now this has become x-axis. The one that is at 0 voltage will refer to the FC. Okay, so it's actually the same thing. Positive will have higher frequency, negative will have lower frequency. Okay, it just flip on it. Okay, so these are the demodulator part. Okay, so they again using the formula to demodulate. Okay, one thing good about this is everything can be done using mathematics. It's not something we look on the table. It's not a lookup table. Just use formula and then we can immediately decode the voltages. Okay, so same thing here. The idea is exactly the same. But instead of using Kf, we change it called Kb. Okay, but it's actually quite straightforward when you're doing demodulation. Okay, and the K given has to be the one talking about this gradient. Okay, the idea is the same. Okay, now you just draw the other way around. Okay, same thing. Now from y-axis become x-axis. Okay? And the KD has flipped. Whatever happened here is now upside down. So if I give you KF, can you tell me what is KD? Wrong. Look carefully. If I give you KF, it's upside down. It's 1 over that thing. You remember? That's not what it is. F over B, right? Now it's B over F. So it's upside down. So if I give you KF, can you write the KD? Just invert it. Okay? Invert it. Okay? Be careful, huh? Okay, so this one is the same. Okay, so if you already done one for the modulation, and they ask you to repeat on the modulation, actually it's very simple, just copy. But just remember to copy the different axis. Okay, so just an example on how to draw this one. Okay, just an example on how to draw this one. Just now if you remember, okay, if you remember just now we have 110 and 90, right? So this is 110, this one is 90, this one is plus 2, this one is minus 1. Okay, just the upside down. Okay, so it's not difficult. Just if you know one, the other one is just over there. Just flip it.
So KD, the D means what?
Modulator.
Demodulator.
Okay, this one. Okay. The minus sign is put in because the minimum is negative value. Okay, so it's just a change in the sign. Okay, the output has the same shape but need not be the same size. Is it okay? No. Why not?
VO have the same shape.
No, the thing is that, you see,
VO is the same.
when voltages, what does it translate to voice or sound? Volume. That one is just volume. But the pitch and everything is still the same. So it's just louder and softer. The one I can get an amplifier and put it out again. Okay? I cannot expect exactly the same. Because first, when you speak that time, I wouldn't know I don't want to keep the volume. Okay, I just need to send the message across. After that I can boost up the volume. Because some of the thing is that it's so smart that you know the environment and it can even boost up higher. Auto adjustment. There are some phones that can do auto adjustment, suddenly become louder. Because they know your environment is very loud. Okay, so these are the things that could be built in. So why do you want to even control? Some people really cannot hear. They want to adjust. So we give them the flexibility.
Also there is a standard, right? If it's too high, amplitude or too low.
The chances it will be lower, it will not be higher. Noise. Noise. We will not make it higher. Even if it's higher, it will be higher together. The chances it will not be higher. Overlap? No. If the overlap is low. Okay, it's just the amplitude. We're talking about amplitude. When you say the size, actually we're talking about amplitude. We want proportionality. This is proportional. Okay. So what we mean by proportional? It means that everything is the same, but there's a chance that it will be delayed, which is not factored here. A delay is okay, acceptable, but not too much. Okay, amplitude not too high, never mind, I can boost it up. All this can be resolved at the end. Okay, but delay is something we have to accept, but over time it actually becomes shorter and better. Okay, we make sure we don't have this. All this correction is actually done at the receiver end when you receive actually some sounds very real time. So that's why most of the time we don't say things are real time. It's not real time. Whenever we have anything, it's real time. Your soccer match is never real time. Okay, so you have the modulator, you have the demodulator to get back the same shape, right? Not the same material. Okay? So this is the modulation. Then it's sketch the demodulation. So you need to sketch this one. Okay? Okay? So this is what we do. So if I give you that one, you can draw this one. Okay? So when you do one, actually it's like doing for both. Okay. It should be complete, and this one should be plus 2 and minus 2. Right? Plus 2 and minus 2. For completeness. Actually, one thing that is not very nice and not very correct is it should stop here. It doesn't exist. Actually, it should stop here. Why? Because you won't have any 2.5 volt. So it will not happen. You got to draw it.
Then on top also stop at 1
I know, yeah. Right.
This should be
Yes. But I think you didn't plan for it, so they didn't go.
then they can do symmetrical two times right triangle.
Although it's so complicated. Okay, so now they give you, if KD is 0.1, sketch the new VO. Okay? The shape is the same. The thing is parallel. Do you realize it? You see this? Yes. If you do the other one is actually 0.2. You do this, what does it mean? It means actually the maximum you can get is plus minus 0.1 only. Which means the volume is, the voltage is different, but the shape is exactly the same. That's what they're trying to say.
The shape same.
Yes. Okay? The most important is the shape. Because in frequency we are looking for shape, we're not looking for everything. I'm looking for the period and the frequency. I'm not looking for shape. Oh, sorry, I'm not looking for the
Looking at the pattern.
Yes.
Looking at the pattern.
Okay, so this is what you can show this, which means that you only have plus minus 1. Okay, the reason is why is this so? It's because when I send out 2 volts, okay, because at the source I send out can be 2 volts, but when the time I receive, it could have a lot of noise and the signal very weakened. So that's why you don't have 2 volts. Okay?
You send 2 volts in the peak to peak.
Yeah, just now the one. We send 2 volts, but it doesn't mean that our output will be a 2 volt. Yes. So in the event where I only have 1, but that will only affect the volume, but not the modulation. I can still do it properly. Okay? I can still know what is the message.
Then not consider the modulation.
Okay, that one is another thing. Go ahead. Okay, so this is what they're doing. I think you need to know at least 1 or 2 examples in case they ask you. PLL is face-off loop. And you remember 1 or 2 in case they ask you for example. So what kind of modulator can it be? Face-off loop and all this thing.
Ratio detector.
Okay. Let me see whether it is. Yeah, because the rest is all mathematics. Yeah.
Then go home and study.
For those who are interested in the mathematics, that's all you get.
Then go home and study mathematics.
No, you don't need to because